Hello, friends. We are back of episode 121 of the Our Weekly Highlights podcast. This is the weekly podcast where we showcase the brilliant innovations and great resources that are being surfaced on the Our Weekly website every single week. My name is Eric Nance, and I'm so happy you joined us today. And speaking of us, I cannot do this podcast alone because I have my awesome co-host with me, Mike Thomas. Mike, how are you doing this morning?
I'm doing okay, Eric. It's tough week to be a Boston sports fan. The Bruins in hockey had a heartbreaking loss this past week, and then the Celtics basketball team seemed to be affected by that because they lost, I think, their first game of their playoff series, second round last night. So that's all. But we got the highlights, so.
We got
We're
the
good.
highlights to cheer you up, although it is an odd coincidence that in both cases a team from South Florida did them in. What are the odds of that, right? My goodness. So
That's
for
true.
our listeners in Florida, it's a great time for you if you're in the sports world, but there's still a long ways to go. So and
Florida hockey doesn't seem to make any sense, but they're good.
yeah, apparently they got jealous of Tampa getting all those cups, and now they want to try and get their hands on one too. But yeah, it's been an eventful first round. I'll be starting my second round exploits tonight, watching as I do various data science hacking around on my computer, multitasking for the win. But we're not multitasking here. We are firmly focused on episode 121 here, and our curator for this week's issue is the esteemed Colin Fay, who, of course, we admire greatly for all of his exploits with Golem and other awesome R packages. He has curated this issue that just hit the interwebs about an hour as we're recording this, but we got some great thoughts to share with you. And, of course, he had tremendous help from our fellow Our Weekly team members and contributors like all of you around the world. So let's dive right into it. Now, in 2023, Mike, I think you would agree, we have access to a whole bunch of resources from an educational standpoint in data science and statistical programming, whether it's online courses, university courses that are spooning up in data science, and a lot more. Now, there are some areas that become pretty vital to what may become our eventual career that are not covered adequately, or perhaps not even mentioned at all in our training. So yes, as I said, we got some great resources online for getting started with R, creating your data science workflows, interactive analyses, and a lot more. But not as much for how you can effectively develop these workflows or capabilities in a team environment, and ensuring that the code you are creating that is, as the engine to that data science, maybe machine learning pipeline or interactive application or R package, that it's production ready in more ways than just saying, hey, it just works. Well, one very effective practice that I think deserves a lot of attention is doing effective code reviews, even if that team is a size of one, because you'll hear my thoughts later on, it's never just a team of one. But apparently I wasn't alone in thinking this, because our first highlight comes from Matt Kay, who is a data scientist at College Vine, on his latest blog post and a series of posts about important concepts that they don't necessarily teach you in a data science curriculum, all about effective code reviews. Some of the key nuggets here that I really isolated on is that we may have heard about code review perspectives from those in the industry about it's very important to catch bugs, of course, to make sure that your style is in line with the team's style guide, sure. But it's more than that. There's a social aspect to this. And in fact, code reviews are a fundamental way to provide knowledge transfer between the members of your team. Or, if it is a solo team, future you. And really a great way that this helps is that you tend to avoid what's been deemed as the bus factor. Now, it doesn't have to be as morbid as it sounds, but the idea is you don't want a single point that or someone that maybe has to leave the project or unexpectedly has an issue occur and they can't get back to the project, that suddenly no one knows what to do next. That's a bad situation. I've been there on the receiving end of it earlier this year, and it was not pleasant. So take it from me, you want to avoid it. But code reviews are a great way to avoid it because now you're already bringing someone else up along the way into the solutions that you and your team are developing. And what are ways to make sure that the team, or like I said, future you, can really understand what's happening? Well, there is a bit of an art as well as a science in writing effective code, making sure that certain pieces are easily understood. And Matt continues with an example in this post that illustrates what would be probably a very realistic code review snippet that you might be tasked to review, where it's grabbing data online from an API endpoint to deal with census data and produce some additional summary metrics. But you'll see in the snippet, if you look at this blog post after the episode, that the code has no comments at all. It's doing what looks like a GET request with the HTTR package, but there's no real rhyme or reason why the codes were chosen and the reason for the derivations. Now, there's no bugs in it. It works. Maybe that's good enough. Well, maybe not, actually. Because what if someone else has to take over that snippet? How are they going to understand why they chose the certain codes they did? Well, in the next part of the blog post, Matt talks about, here is some of the feedback I would give, such as, what do these census codes actually mean? Why did you remove a certain element from the response vector? And just what can we expect from this response from the API endpoint? And that's where the next snippet of code shores up those issues. Very detailed comments in the beginning of the script that talks about what these rather cryptic looking codes actually correspond to in terms of the states that it's trying to aggregate. And then also why they had to do various munging with that response coming back. But see, explainability, that is something where maybe you're on a tight deadline. You just want to write something that works, right? And get it out into production. You're going to regret it. Again, coming full circle here with some stuff I did in the past. I have been guilty of this in the past, but I'm trying to shore up my code documentation practices, especially after reading, very important posts like this from Matt. So I think it's very important to be detailed. In my opinion, you can almost never have too many comments of this magnitude. It's not so much just explaining the what all the time, but giving a great frame of reference, I think, is vitally important to make sure that that knowledge that you had in your head as you're developing these scripts, developing these pipelines, is easily understood in the future. So I think this is a very important topic to put a spotlight on here. And it gave me a little bit of perspective to the early part of my career when I was tasked with analyzing some pretty complex biomarker data coming from the lab and merging that with clinical sets and doing some, basic regression modeling or other inferences. Well, little old me just had basic biology and chemistry classes in undergrad, but I had next to no knowledge of what these protein biomarker codes meant or these microarray gene expression IDs and what I was going to do with them. So even for my learning, I put comments in, very detailed of what I was trying to accomplish here, because it was a way for me to learn, but also when I finally did get help in certain places, I could easily transfer that knowledge as well. It takes discipline, but I think with effective practice of this, you can write more effective code that does more than just work. So excellent post by Matt. And again, I highly invite you to check out his previous posts in this series that talk about unit testing and other concepts that, again, don't quite get a lot of attention in a typical data science curriculum or pipeline.
This is such an under-discussed topic, and I, for one, am very much here for it. And like you just said, I love that the blog post is part of the series Matt has called The Missing Semester of Your Data Science Education. He has his blog authored with Quarto, and I didn't even realize that you can sort of create a series. This is a tangent now, but you can create a series of posts in a really nice table that's hyperlinked to the individual posts. He check out his blog if you're looking to move your blog to Quarto. I think his blog is a great example of maybe a way to get started and some nice tips and tricks that he has. And I just think it's so cool that he's created these series of posts that he's able to group together. But back to the actual content of this particular post, it reminded me of a book, I believe, that's authored by Jenny Bryan, Jim Hester, Shannon Pileggi, and E. David Aja. And they have many accompanying workshops as well. And the book is called What They Forgot to Teach You About R, which has the unforgettable URL of rstats.wtf if you're looking for it online. So Matt's blog post reminded me of their book because to me, the fact that code review and Git aren't taught in the classroom, I think is creating such a disservice to so many statisticians and quantitative analysts out there once they are actually making the leap out of academia, right? Most of the time into industry is where you're going to find a lot of these software development tools and structures and frameworks in place. And unfortunately, I think this means that folks who want to really succeed in data science, or teams that want to do well, need to be self-taught in a lot of these software development best practices to some extent. And I know that was certainly the case for me, and I imagine that was very much the case for you as well, Eric.
Oh, yes. Learning the hard way, as they say, for sure.
Yes. So, that's sort of a side as well. But in my opinion, one of the big advantages of code review in general, which Matt calls the bus factor, as you mentioned, is ensuring that more than one person can understand your code. So, of course, you may know what your code is doing in your head, right, at the time of writing it. But someone else, or you 6 months from now, may not understand it if your functions are not well documented and well commented. And having multiple people looking at a piece of code and all understanding it can go a long way towards avoiding technical debt. So this is absolutely something that I would recommend on just about every single piece of code that you're going to write, is get as many eyes on it as possible, so that you can sort of ensure that what you are writing is not specific to one person's domain knowledge or one person's expertise, and that others will be able to grok it as quickly as you were when you wrote it initially. So absolutely a great blog post. Those are just some of my thoughts as well. So thanks to Matt.
Yeah, really excellent points. And I think it's really interesting when you're able to integrate this human aspect of code review, and then in preparation for a code review, using some of the tools to make it easier for people to review your code. Now, I'm thinking, I mentioned it a little bit in the beginning, but if your team has a style that you're associating with developing your code in a unified way, maybe running that little linter before you put that pull request in, so that now everybody's looking at it in the same way. That's a little fresh to me, because a couple of years ago, for a major project we had where we had multiple team members working on different modules of a very large, shiny application, it was quite easy to tell who did what module, because the style was completely different. It was hard for me to navigate that effectively. And something we touched on last week, Mike, with the idea of indentation. Oh, they went way beyond 80 characters for their lines, and I was a little annoyed, and I tried to tell them that in a nice way, of course. But yeah, there are things you can do to make it easier to make the review process straightforward. But again, the tools like GitHub and other version control mechanisms make it super easy once you find that snippet that you think needs more explanation, or maybe you want to offer a different approach. You can put that comment right there in the review. And another great inspiration for how these code reviews can be done very effectively. Anytime you look at an R OpenSide package that's being onboarded, just their process of onboarding the package itself is like a massive code review, if you will, of the entire package. And you can learn some great, little bits of wisdom for how the reviewer is approaching that question, or what ideas they have, and what the author of it did to revise it. So that's another case where if you just look out there, there's a lot of great sources of inspiration if you're new to this area, or maybe you have a new team and you want to instill these best practices right now. Some great ways to get started. So I think Matt does a terrific job of highlighting this. And yes, this would have been extremely helpful if I'd had this before my career started, but better late than never.
Yes, I think it's very important for you as a data science manager, especially to take the time to educate both yourself and your team on how you are going to structure your code review and how at a higher level you're going to structure collaboration within your team.
Yep, and we're going to keep on that, you might say, collaborative bit with respect to the R language itself in our next highlight here, because if there was ever a year that we've seen the power of integrating R with other software languages, I dare say 2023 is near the top of the list. And I'm thinking in terms of some of the great discussions we've had in previous episodes about the advent of WebR for bringing R directly into your web browser thanks to the power of WebAssembly and JavaScript. Now, we're going to take a little bit of a step back from that interesting journey so far. But imagine that you and I, Mike, are looking to build our next great shiny app, and we need a great visualization. And we stumble upon this great snippet of JavaScript code or maybe a JavaScript module, and we want to bring that into R. Now, what would be one approach for that? Well, it could be making an HTML widget out of it, and that's a perfectly valid approach that we'll be hearing about shortly. But there may be another way. What if you can write an R function that is automatically converted to the JavaScript code needed to interact with that JavaScript library? Woo, the plot thickens, as they say. Well, we're going to dive right into this idea because it's been possible ever since 2020, with seeds even earlier than that, via what's called the Sketch package. And we have a great blog post here from the R Consortium where they interviewed the author of Sketch, Jackson Kwok, who is a postdoc in econometrics at St. Vincent's Institute of Medical Research in Australia, for this really comprehensive interview talking about the origin story, the current status, and the future plans of the Sketch package. So the idea of Sketch actually began at one of R OpenSci's unconference events, and this one called the R Oz Unconference in 2017, that was again in Australia. And in fact, fellow R Weekly team member Jonathan Carroll had an idea at this very conference where he wanted to port over the P5 JavaScript library that does some really interesting, comprehensive dynamic visualizations with some pretty nice syntax. He was thinking, what if we could make that an HTML widget? And that got a lot of attention, and that was, again, worked on quite extensively at this unconference. It actually became basically a building block of an HTML widget called Realtime, which aimed to bring kind of like a ggplot2 animated style to visualizing real-time data as it's progressively being read into the session. Now, after that unconference event, Realtime itself was quite successful, but Jackson wanted to pursue this idea even further, and he extended this paradigm that was pioneered in this Realtime package in such a way that it became a general foundation for transpiling R code into JavaScript code via a series of internal functions and parsers, and that's how Sketch was born. And, well, what is Sketch under the hood, right? Well, you can think of Sketch as taking some of the great technical bits that Shiny has, such as the communication between the R process and the client side, i.e. the web browser, via what's called WebSockets, to give the user this canvas of JavaScript to play with. And then being inspired by other languages that were able to transpile their domain code into JavaScript, Jackson had a play at trying to do that from the R side, and it actually worked pretty easily in his initial explorations many years ago. So again, the main idea is you create R functions that are going to interact with this JavaScript library that you found, and then you construct it in such a way where you're basically passing lists and object references to the JavaScript library, but then there are built-in parsers that if you annotate your code script at the top with a special comment, not unlike what you might do for Plumber, but to declare what script is going to handle that compilation, then it'll translate that code on the fly in that session, give you that WebSocket-like functionality, that bidirectional communication, and then you can embed this visualization or this interactive widget into your plain R session, into your RStudio environment, and even in R Markdown or Shiny apps. Like, you can put it almost anywhere. This seems really, I can't believe it. I would think there would be so many hoops to jump through to even make this possible. But apparently, Jackson has done a solid foundation for this. And so the post talks about how the rest of the story came together and how he had a great suggestion from a fellow colleague of his, Kate Saunders, who coincidentally was a previous guest on the Shiny Dev series. There's a little plug for you. On what if we get some additional funding for this project, now that his academic funding was running out for this particular idea, from the R Consortium Infrastructure Steering Committee. And sure and lo and behold, they were able to get accepted as a sanctioned project, and they've been working very hard on it ever since. So that's another win for, if you have a great idea that you can think will benefit the R community, the R Consortium is an excellent way to go to get some financial support for that and get some much needed resources and, frankly, a lot of help to even broadcast this idea out to the community. And of course, I speak to that as somebody who's directly involved in a very major project as we speak in life sciences with our submissions that the R Consortium is spearheading as well. So great kudos to Jackson and Kay for exploring this idea. But he's not done yet, folks. In terms of what he wants to do in the future, he's seen the positive attention that WebAssembly is bringing in the world of JavaScript and R and Python. And he's prototyping ways of getting that functionality into Sketch or maybe some additional packages as he's created since then, one called Animate, to take that idea even further. So again, really great insights into not just what Sketch is, but the journey behind it, because I think it's such a fascinating story to hear how these ideas are born and the life that they take after, really diligent work and community feedback. Another testament to the open source nature of R. And again, I want to have a play with this because I think this is a great intermediary between making that HTML widget yourself and trying to figure out, well, if no one else has done it in the community, how can I kind of get started with it and take myself to that next step? So I'm really intrigued by this, and it's definitely something to be explored later this year.
So much R and JavaScript intermingling nowadays. It's hard to keep up with it all, from WebR to observable JS. I think there were some recent demos or tutorials online around that, to now Sketch. And this is most definitely the future in my eyes. And it's great to see the R Consortium and the Infrastructure Steering Committee recognizing this and directing funding towards this type of effort. I think it's really important. How this actually all works under the hood, Eric, you did a great job explaining it, but it's still a little bit over my head.
I did my best. I'm still learning too.
I got to dive a little bit deeper to grok it all. But in the blog post, there's a GIF of pink balls falling down a pegboard and ending up in one of 7 different slots at the bottom of the board. It's sort of a simulation exercise. And I think this could be a great tool, Sketch, for demonstrating simulation or how the random sampling functions work in R from a visual perspective for folks that learn better that way, like myself. So lots of utility. There's examples in the repository, I believe, of how to utilize Sketch in a Shiny app in particular. So I'm excited to check those out. And kudos to Jackson for really taking this idea from the unconference and running with it. And I really especially like reading this interview and getting the perspective of the human behind the software, and not just reading only the technical specs of the project, but a reminder that there are actual incredible people behind these projects. So I really enjoyed the R Consortium conducting this interview with Jackson and getting to see that side of it as well, the human element.
Yeah, I mean, that side of it alone is one of the biggest reasons I start these various adventures like this in the dev series and the OGR podcast before this, of like getting behind the behind the code, right? I mean, there's fascinating stories in this community. And yeah, the ARC Consortium has been really top notch of, publishing these interviews and these other deep dives into these projects because they're helping the community in so many ways. These ideas and getting support for that, I think, is massive to the adoption of R in future generations because we want to keep R going, right? We don't want it to die a slow death here. We think it's only getting started for just how far we can take it. So JavaScript does seem like the next frontier, and yeah, I've been knee deep in customizing various JavaScripts widgets at the day job. Viz Network, you and I need to have a talk. That's a long story for another day, but it's a learning journey. But it's great to see others explore this too, and I'm learning from them as I go.
I think your trials with Viz Network is turning maybe from a battle into a war at this point.
It is, but the end is in sight. Conquered yet another major feature. Oh, I feel like I need to do a live stream about this because it is, how should I say this? The leaders in this space will laugh at my exploits here. But you know what? You all got to start somewhere. I'm one of those people.
Absolutely. That's awesome.
And yes, it is great, Mike, once we plan ahead on these projects, like I thought I had everything figured out with Viz Network, but no, there's always like some scenarios that the end users are going to find that I didn't really forecast. Now, you can put yourself in despair and wonder, okay, how am I going to deal with this? Well, there are some techniques you can employ right now that at least put yourself in a bit more of a better position to defend that great R script or that package or other pipeline from crashing when you least expect it. And that's where the concept of error handling comes into play. Because again, nothing almost ever works perfectly all the time. And our last highlight here comes from Gustavo Santos, who is a data scientist at Food Lion, with a very short but sweet tutorial here on how you can perform error handling in R from both R and Python, and really how similar they look. So Mike, why don't you tell us about the error handling journey here?
Yes, this was a great blog post about the two main methods of error handling in R and Python. And in R, or base R at least, we use try catch to decide what action to take when a function throws an error, a warning, or a message. And in Python, the except, EXCEPT verb, is the equivalent to the catch portion of R's try catch and deciding what to do when that error does pop up. Essentially, instead of sort of stopping the execution logic, it's how are we going to handle this so that we can continue. And lately at Catchbrook, we have been wrapping functions in pers safely function to capture error messages without our Shiny apps disconnecting and actually making it possible to show the user the error message instead of someone having to check the server logs. And previously we were doing a lot of try-catch work to sort of do the same thing. So it's a very useful tool, and if you are interested in taking a look at the safely function from per as well, just to throw out some additional options as well, that function always returns, I believe, a 2-element list. And the first element in that list is the object that the function returns. And this will be null if the function threw an error, but it won't be null if there was no error. And the second element in that list would be the error message, which would be null if the function did not throw an error. But it's nice that you have access to that exact error message in an object that you can then use downstream in your code. So what we do is we check to see if the second element is not null, and then we'll return the error message to the user in a modal dialog box. That's a free Catchbrook tip for anybody out there that's interested in improving the error handling within your Shiny apps, because we always have to throw in some sort of Shiny reference, or otherwise it would not be a podcast by Eric and myself. But absolutely take a look at this blog post if error handling is something that you run into in either R or Python, that you are trying to make a smoother process. And I think this is sort of especially important in an application setting in some sort of live data product setting, because this accept is really for catching those edge cases that you did not code up in the first place, that you did not anticipate in the first place, and trying to smooth out the user experience when these error messages do arise, as opposed to sort of a much more straightforward, piece of code where you sort of know exactly what's coming in all the time and you know exactly what's going to go out. So great blog post. Absolutely check it out. And Eric, what did you pull out of this particular blog post yourself?
Yeah, it's really being prospective about these approaches, but I think it's your gateway into this strategy. I think having clear ways of dealing with the errors downstream in these pipelines is just as important. So I think this is great to get you educated on the fact that these concepts exist. But yes, Mike, just like you said, in a major app I made, we have a part in the step before they launch that massive HPC execution of the analysis where we do a little check. Make sure the user didn't specify anything incorrectly, because we don't want the app to get destroyed during that complex simulation. So what we do is we run that function in a separate R process, but with either a try catch or a per safely call. We grab any errors that did occur, surface them up front and center, and say, oh, you got to change this because XYZ. Because the last thing you want is burning up resources when they're going to fail anyway. So that's another pro tip from Eric's exercise in the trenches of Shiny app situations. But I think, dealing these messages effectively for the user. And another case where this can come up is when you're doing a data analysis or making your own data, and maybe the distribution is completely out of whack, and you're running that Bayesian model and it just cannot converge for some reason. So being able to be prospective of dealing with those issues is also critically important. But in my most, at least internally at the day job, famous example of this, it pains me to say this, but I had to write a package that imports data sets, and sometimes it doesn't work as expected. So then I have to do a try catch to go to a plan B in that situation, instead of users complaining to me that, Eric, your package doesn't import that SAS data set. I'm like, what can I do? I don't have access to the data you have. So I got to be defensive about this as well. So I've been well versed in this, frankly, out of necessity. But there may be a point in your various data science journeys for you listening out there where being defensive and error handling will save you a boatload of time.
Yes, and we're gonna bleep out that 3-letter word in post production, I'm sure. But that was a great a great story for the users out there. And like you said, if you are able to sort of capture those error messages and surface them up to the end users sooner rather than later, instead of someone having to always go in and check the server logs, that can go a long way towards time savings for your team.
Yeah, these things really add up. Every little thing may not seem that outstanding on its own when it's the sum is greater than the individual parts, or whatever that phrase is. It is very much appreciated by your end users and, frankly, you as a developer as well. Well, there's a lot to appreciate in this issue as well. The Collins put a boatload of content for us to enjoy learning about great new innovative uses of R, and we'll take a couple minutes here to talk about our additional finds here. And for me, it wasn't just one. There is basically a series of about four blog posts about using Shiny and a new package to me called tidyaml to have a nice front end for building machine learning models in an AutoML mindset, but with tidy models as the back end. These have been authored by Steven Sanderson, but I think this is a great example of making your initial journey to creating machine learning models a lot more accessible to build and to quickly get into a working state. So highly recommend to read through those 4 posts, because that'll be something I'll be following up with after this podcast as well, as we're starting to build more ML pipelines in our daily work. So excellent series of posts by Steven on that. Mike, what did you find?
Well, Tal Galili, who's the maintainer of the install R package for installing and updating R, on the Windows operating system is looking for a new maintainer of the package. And I know, unfortunately, out there are a lot of folks that use Windows either by choice or not by choice, Eric, and the installer package can be super helpful. It's one that I've used in the past as well for updating my R installation. And Tal switched from Windows to Linux 5 years ago, and obviously it's difficult to maintain a package dedicated to a particular operating system when you are not working on that operating system yourself. So this is a call for help. He is seeking a new maintainer for this very, very popular R package specific to the Windows operating system. So if you are someone who's passionate about R, passionate about Windows OS, I would reach out to Tal and see if there's a way that you might be able to help him out.
Yes, this brings back some very memories that are quite recent. We're in this R consortium pilot project for FDA submissions. Guess who had to spin up Windows virtual machines to make sure that the Shiny app worked in a Windows environment? Yes, that was yours truly here. But I did it because it was quite necessary for that project, but I can't say that was ideal. But for those of you that are in a similar situation, and perhaps those of you listening that do want to help out Tal, first of all, I'm sure he would greatly appreciate it, but there are some great utilities to make that Windows environment exploration a lot easier about literally getting that other system you might have in the closet or buying a new one just for this. I'm going to put a link in the show notes to a project called QuickMU, which is an awesome way that on Linux I could bootstrap that Windows virtual environment through very simple functions, authored by, I'll call him a good friend because he's helped me out quite a bit, Martin Wimpress from the Linux community. Give that a shout out give that a look, I should say, if you need to look at Windows stuff on the Linux side. Again, I don't do it very often, but when I do, I use QuickMU.
That's a great tip. That's a great tip.
Yes, and like I said, every R Weekly issue has a boatload of tips as well. And of course, it is very much driven by you, the audience, on where the project goes via your pull requests, your suggestions for great resources. And so another concept I talk about quite a bit in this podcast is the idea of value for value. If you find what we're doing on this show and the R Weekly project itself helpful to your journey in data science, we'd love to hear from you. We'd love to have your contributions to the project. And while I don't have specific feedback this week in terms of boosts, I did want to call attention to a response that I got from a good friend, John Harmon, who many of you know as the great leader of the R for Data Science initiative and that awesome organization. He was asking me about other ways that we can help produce a show. He was a little skeptical of what I've been talking about with the idea of boosts in these podcast apps. And while I probably need to do a dedicated episode to do this topic justice, what I want to say is that value can come in many forms, right? I mean, I think it would be fun if you took the approach of what a recent listener, Chris, did and sent us a fun little boost to give us a little encouragement on one of those new podcast apps. But that's not the only way. Like I said, our Weekly is built by the community for the community. And if you find a great resource, send us a pull request to the upcoming draft, and we'll be glad to get that into the future issue. Spreading the word about our Weekly itself and this podcast is a tremendous help for us. I am not going to be one of those people that begs you to put a review on iTunes or whatever. You don't need to do that. Just share it to your friends. That's all we ask. And certainly if you're inspired, I got links in the show notes. If you're interested in learning more about this concept, it's right there for the taking. But in any event, we love hearing from you nonetheless. So giving us a pull request at rweekly.org is a great way to help the project itself. And we have a contact form in the episode show notes if you want to get in touch with us directly there via a simple web page. And also you can give us a shout on social media. I am sporadically on Twitter with @TheRcast and also on Mastodon at our podcast at podcastindex.social. And Mike, where can the listeners get a hold of you?
Likewise on Twitter at Mike_Ketchbrook, KETCHBROOK, and on Mastodon at Mike_Thomas at fostodon.org.
Awesome stuff. we will see you for episode 122 of the Our Weekly Highlights podcast next week.